Mapping well logs using Transform. To map well logs in Transform, we would once again click on our mapping icon on the top right. When we select the data type, we're going to select well logs. We'll press add, and then we'll select the well log that we'd like to map. Now we have the choice of mnemonics versus aliases, and I'm going to choose gamma ray under the aliases. Now the default that it starts with is takes the entire log and will take the average from the top of the log to the base of the log. But we may want to look at a specific interval. So once again, we can actually use the slider bars to look at specific depths. But what might be make more sense is actually, let's pick between two tops. So we can use well tops, well top aliases, or well bore interval. But I'm going to choose well top aliases. And I want to look at the values between the Wolfcamp A and the lower Wolfcamp A. Now, one thing to note here are the counts, and this is present in any type of mapping we're doing. The bottom number tells you how many wells actually have gamma ray logs. So in this case, 5,253. The value above tells you how many meet the criteria, having Wolfcamp A to lower Wolfcamp A, as well as having the gamma ray log. So that cuts our data down to 1507. So let's press apply just to see what that looks like. Now, once again, we can sort our values by pressing the gamma ray button here, or we can also sort on the well UWI. One of the things that is unique to mapping well logs is this button called Aggregate Options. So at the moment we're looking at the mean value, but we can look at the mean absolute, the median, the root mean squared, minimum, maximum, the sum absolute, the thickness weighted, attribute thickness, net proportion, and net thickness. Now, the thickness weighted takes the sum of the well log value at every measured depth sample and multiplies it by the true vertical thickness of the sampling interval to produce a value with units of attribute length. It's basically a phi-h map, but in this case, since our sampling interval is 0.5, we'd actually have to divide it by 2 to have a phi-h. Now, attribute thickness is basically the same thing, except it allows you to apply a cutoff. So if you only want to look at values that are greater than 90, you would apply that here. Net proportion will tell you the proportion of that log within that interval that meets that criteria. So you're saying, okay, well, what percentage will be greater than 90? And it will tell you that percentage. The one I tend to use the most is the net thickness. So if it's basically a net pay map but once again, since we're dealing with a sample interval of 0.5, we'd have to divide it by 2. But if I want to say, okay, well, within that zone, how many feet are going to be greater than 90? So I'll press apply. We'll close that. And then we can see that mapped out through here. But once again, we're going to have to divide by 2. So that is a different thing that only is applicable to well logs. Now, we did go through most of these other tabs when we went through well tops. So once again, select, deselect. We can look at the histogram of the data, select portions we'd like to display, as well as outlier workflows. We can style it here through the layers. We can also trim the data, as well as see the data points. Now this I find is very useful with well logs because you tend to get a little more outliers. So just say this one here I feel is not a valid data point. I can click on that. I can see it highlight here, unclick it, press apply, and I can remove that. Once again, we have choices for different algorithms, which we can select here, as well as grids that we would like to choose. So we can press select grid. We can search for a grid by typing on the bottom. We can apply that. And when we're happy, we can actually save this as an attribute. So this would be a net thickness, and we're going to save that as a horizon property, and we would put that under the Wolfcamp A, SAM, and create. And now it's actually saved in the database that you can just throw on later. Thank you for watching well log mapping.